create a function anonymously and allow you to pass it in, for instance, as some value here. So let's now change students.csv to contain not students' houses at Hogwarts, but their homes where they grew up. So Draco, for instance, grew up in Malfoy Manor. Ron grew up in the Burrow. Harry grew up in number 4 Privet Drive. And according to the internet, no one knows where Hermione grew up. The movies apparently took certain liberties with where she grew up. So for this purpose, we're actually going to remove Hermione because it is unknown exactly where she was born. So we still have some 3 students. But if anyone can spot the potential problem now, how might this be a bad thing? Well, let's go and try and run our own code here. Let me go back to students.py here. And let me propose that I just change my and run our own code here. Let me go back to students.py here, and let me propose that I just change my semantics because I'm now not thinking about Hogwarts houses, but the student's own home. So I'm just going to change some variables. I'm going to change this house to a home, this house to a home, as well as this one here. I'm still going to sort the students by name, but I'm going to say that they're not in a house, but rather from a home. So I've just changed the names of my variables in my grammar in English here, ultimately, to print out that, for instance, Harry is from number 4 Privet Drive, and so forth. But let's see what happens here when I run Python of this version of students.py, having changed students.csv to contain those homes and not houses. Enter. Our first value error. Like the program just doesn't work. What might explain this value error, the explanation of which rather cryptically is too many values to unpack, and the line in question is this one involving split. How did all of a sudden, after all of these successful runs of this program, did line 5 suddenly now break?
In the line in students.csv, you have 3 values. There's a line that you have 3 values and students.
Yeah, I spent a lot of time trying to figure out where every student should be from so that we could create this problem for us. And wonderfully, like the first sentence of the book is number 4 Privet Drive. And so the fact that that address has a comma in it is problematic. Why? Because you and I decided some time ago to just standardize on commas, CSV, comma, separated values, to denote the we standardized on commas in order to delineate one value from another. And if we have commas grammatically in the student's home, we're clearly confusing it as this special symbol. And the split function is now, for just Harry, trying to split it into 3 values, not just 2. And that's why there's too many values to unpack, because we're only trying to assign 2 variables, name and house. Now, what could we do here? Well, we could just change our approach, for instance. Like one paradigm that is not uncommon is to use something a little less common, like a vertical bar. So I could go in and change all of my commas to vertical bars. That too could eventually come back to bite us, in that if my file eventually has vertical bars somewhere, it might still break. So maybe that's not the best approach. I could maybe do something like this. I could escape the data, as I've done in the past, and maybe I could put quotes around any English string that itself contains a comma. And that's fine. I could do that, but then my code, students.py, is going to have to change too, because I can't just naively split on a comma now. I'm going to have to be smarter about it. I'm going to have to take into account split only on the commas that are not inside of quotes. And it's getting complicated fast. And at this point, you need to take a step back and consider, you know what, if we're having this problem, odds are many other people before us have had this same problem. It is incredibly common to store data in files. It is incredibly common to use CSV files specifically. And so you know what? Why don't we see if there's a library in Python that exists to read and or write CSV files? Rather than reinvent a wheel, so to speak, let's see if we can write better code by standing on the shoulders of others who have come before us, programmers past, and actually use their code to do the reading and writing of CSVs so we can focus on the part of our problem that you and I care about. So let's propose that we go back to our code here and see how we might use the CSV library. Indeed, within Python, there is a module called CSV. The documentation for it is at this URL here in Python's official documentation, but there's a few functions that are pretty readily accessible if we just dive right in. And let me propose that we do this. Let me go back to my code here, and instead of reinventing this wheel and reading the file line by line and splitting on commas and dealing now with quotes and privet drives and so forth, let's do this instead. At the start of my program, let me go up and import the CSV module. Let's use this library that someone else has written that's dealing with all of these corner cases, if you will. I'm still going to give myself a list, initially empty, in which to store all these students. But I'm going to change my approach here now just a little bit. When I open this file with with, let me go in here and change this a little bit. I'm going to go in here now and say this. Reader equals csv.reader, passing in file as input. So it turns out, if you read the documentation for the CSV module, it comes with a function called reader, whose purpose in life is to read a CSV file for you and figure out where are the commas, where are the quotes, where are all the potential corner cases, and just deal with them for you. You can override certain defaults or assumptions in case you're using not a comma, but a pipe or something else. But by default, I think it's just going to work. Now, how do I iterate over a reader and not the raw file itself? It's almost the same. The library allows you still to do this. For each row in the reader. So you're not iterating over the file directly now. You're iterating over the reader, which is, again, going to handle all of the parsing of commas and new lines and more. For each row in the reader, what am I going to do? Well, at the moment, I'm going to do this. I'm going to append to my students list the following dictionary. A dictionary that has a name whose value is the current row's first column, and whose house, or rather home now, is the row's second column. Now, it's worth noting that the reader for each line in the file indeed returns to me a row. But it returns to me a row that's a list, which is to say that the first element of that list is going to be the student's name, as before. The second element of that list is going to be the student's home, as now before. But if I want to access each of those elements, remember that lists are 0 indexed. We start counting at 0 and then 1 rather than 1 and then 2. So if I want to get at the student's name, I use row bracket 0. And if I want to get at the student's home, I use row bracket 1. But in my for loop, we can do that same unpacking as before. If I know this CSV is only going to have 2 columns, I could even do this. For name home in reader, and now I don't need to use list notation. I can unpack things all at once and say name here and home here. The rest of my code can stay exactly the same, because what am I doing now on line 8? I'm still constructing the same dictionary as before, albeit for homes instead of houses. And I'm grabbing those values now, not from the file itself and my use of split, but the reader. And again, what the reader is going to do is figure out where are those commas, where are the quotes, and just solve that problem for you. So let me go now down to my terminal window and run python of students.py and hit enter. And now we see successfully sorted no less, that Draco is from enter. Here's how you say good thing in the name of for sales fields where the yes well this clear that better should we go we can program we know people need enough to change that's around any English string that itself contains a comma, and that's fine. I could do that, but then my code students.py is going to have to change too, because I can't just naively split on a comma now. I'm going to have to be smarter about it. I'm going to have to take into account split only on the commas that are not inside of quotes, and it's getting complicated fast. And at this point, you need to take a step back and consider, you know what, if we're having this problem, odds are many other people before us have had this the same problem. It is incredibly common to store data in files. It is incredibly common to use CSV files specifically to write. If I know this CSV, really good question.
Stuff to make file time. But
In reading each of those commas and splitting.
so my questions are related to something a bit in the past. I recognize that you are reading a file every time you we're assuming that we have the CSV file to hand already in this case. Is it possible to make a file readable and writable? So in case if you want, you could write some stuff to the file, but then at the same time you could have another function that reads through the file and does changes to it as you go along.
A really good question, and the short answer is yes. However, historically, the mental model for a file is that of a cassette tape. Years ago, not really in use anymore, but cassette tapes are sequential, whereby they start at the beginning, and if you want to get to the end, you kind of have to unwind the tape to get to that point. The closest analog nowadays would be something like Netflix or any streaming service where there's a scrubber that you have to go left to right. You can't just jump there or jump there. You don't have random access. So the problem with files, if you want to read and write them, you or some library needs to keep track of where you are in the file, so that if you're reading from the top and then you write at the bottom and you want to start reading again, you seek back to the beginning. So it's not something we'll do here. Here in class, it's more involved, but it's absolutely doable. For our purposes, we'll generally recommend read the file, and then if you want to change it, write it back out rather than trying to make more piecemeal changes, which is good if, though, the file is massive and it would just be very expensive time-wise to change the whole thing. Other questions on this CSV reader?
Is possible to write a paragraph in that file?
Absolutely. Right now, I'm writing very small strings, just names or houses as I did before, but you can absolutely write as much text as you want. Indeed. Other questions on CSV Reader?
Can a user choose himself a key, like input key will be a name or home?
So short answer, yes. We could absolutely write a program that prompts the user for a name and a home, and we could write out those values. And in a moment, we'll see how you can write to a CSV file. For now, I'm assuming as the programmer who created students. us in that if my file eventually has something like around any keep the data string that itself contains a comma. And that's fine. I could do that, but then my code students.py is going to have to change too, because I can't just not, but then my code students.py is going to have to change too, because I can't just naively split on a comma now. I'm going to have to be smarter about it. I'm going to have to take into account split only on the commas that are not inside of quotes, and it's getting complicated fast. And at this point, you need to take a step back and consider, you know what, if we're having this problem, odds are many other people before us have had this same problem. It is incredibly common to store data in files. It is incredibly common to use CSV files specifically. And so you know what? Why don't we see if there's a library in Python that exists to read and or write CSV files. Rather than reinvent a wheel, so to speak, let's see if we can write better code by standing on the shoulders of others who have come before us, programmers past, and actually use their code to do the reading and writing of CSV. I propose that we go back to our code here and see how we might use the CSV library. Indeed, within Python, there is a module called CSV. The documentation for it is at this URL here in Python's official documentation, but there's a few functions that are pretty readily accessible if we just dive right in. And let me propose that we do this. Let me go back to my code here, and instead of reinventing this wheel and reading the file line by line and splitting on commas and dealing now with quotes and privet drives and so forth, let's do this instead. At the start of my program, let me go up and import the CSV module. Let's use this library that someone else has written that's dealing with all of these corner cases, if you will. I'm still going to give myself a list, initially empty. Is each line just an element of, if I want to get at this. However, historically, the mental model for a file is that of a cassette tape. Years ago, not really in use anymore, but cassette tapes are sequential, whereby they start at the beginning, and if you want to get to the end, you kind of have to unwind the tape to get to that point. The closest analog nowadays would be something like Netflix or any streaming service where there's a scrubber that you have to go left to right. You can't just jump there or jump there. You don't have random access. So the problem with files, if you want to read and write them, you or some library needs to keep track of where you are in the file, so that if you're reading from the top and then you write at the bottom and you want to start reading again, you seek back to the beginning. So it's not something we'll do here in class. It's more involved, but it's absolutely doable. For our purposes, we'll generally recommend read the file, and then if you want to change it, write it back out, rather than trying to make more piecemeal changes, which is good if, though, the file is massive and it would just be very expensive time-wise to change the whole thing. Other questions on this CSV reader?
Is possible to write a paragraph in that file?
Absolutely. Right now I'm writing very small strings, just names or houses as I did before, but you can absolutely write as much text as you want. Indeed. Other questions on CSV reader?
Can user choose himself a key, like input. Key will be a name or home.
So short answer, yes, we could absolutely write a program that prompts the user for a name and a home, a name and a home, and we could write out those values. And in a moment, we'll see how you can write to a CSV file. For now, I'm assuming as the programmer who created students.csv that I know what the columns are going to be, and therefore I'm naming my variables accordingly. However, this is a good segue to one final feature of reading CSVs, which is that you don't have to rely on either getting a row as a list and using bracket 0 or bracket one, and you don't have to unpack things manually in this way, we could actually be smarter and start storing the names of these columns in the CSV file itself. And in fact, if any of you have ever opened a spreadsheet file before, be it in Excel, Apple Numbers, Google Spreadsheets, or the like, odds are you've noticed that the first row very frequently is a little ditch. You have storing the have to unpack things manually in this way. We could actually be smarter and start storing the names of these columns in the CSV file itself. And in fact, if any of you have ever opened a spreadsheet file before, be it in Excel, Apple Numbers, Google Spreadsheets, or the like, odds are you've noticed that the first row very frequently is a little different. It actually is boldface sometimes, or it actually contains the names of those columns, the names of those attributes below. And we can do this here in students.csv. I don't have to just keep assuming that the student's name is first and that the student's home is second. I can explicitly bake that information into the file just to reduce the probability of mistakes down the road. I can literally use the first row of this file and say name, comma, home. So notice that name is not literally someone's name, and home is not literally someone's home. It is literally the words name and home separated by a comma. And if I now go back into students.py and don't use CSV Reader, but instead I use a dictionary reader, I can actually treat my CSV file even more flexibly, not just for this, but for other examples too. Let me do this. Instead of using a CSV reader, let me use a CSV dict reader, which will now iterate over the file, top to bottom, loading in each line of text not as a list of columns, but as a dictionary of columns. What's nice about this is that it's going to give me automatic access now to those columns' names. I'm going to revert to just saying for row in reader. And now I'm going to append a name and a home. But how am I going to get access to the current row's name and the current row's home? Well, earlier I used bracket 0 for the first and bracket 1 for the second when I was using a reader. A reader returns lists. A dict reader or dictionary reader returns dictionaries, one at a time. And so if I want to access the current row's name, I can say row quote unquote name. I can say here for home, row quote unquote home. And I now have access to those same values. The only change I had to make, to be clear, was in my CSV file, I had to include on the very first row little hints as to what these columns are. And if I now run this code, I think it should behave pretty much the same, Python of students.py. And indeed, we get the same sentences. But now my code is more robust against changes in this data. If I were to open this CSV file in Excel or Google Spreadsheets or Apple Numbers and for whatever reason change the columns around, maybe this is a file that you're sharing with someone else, and just because they decide to sort things differently left to right by moving the columns around, previously my code would have broken because I was assuming that name is always first and home is always second. But if I did this, be it manually in one of those programs or here, home comma name, and suppose I reversed all of this. The home comes first, followed by Harry. The borough, then by Ron. And then lastly, Malfoy Manor, then Draco. Notice that my file is now completely flipped. The first column's now the second, and the second's the first, but this be it manually in one of those programs or here, home comma name, and suppose I reversed all of this. The home comes first, followed by Harry. The borough, then by Ron. And then lastly, Malfoy Manor, then Draco. Notice that my file is now completely flipped. The first column's now the second, and the second's the first, but I took care to update the header of that file, the first row. Notice my Python code, I'm not going to touch it at all. I'm going to rerun Python of students.py and hit enter, and it still just works. And this, too, is an example of like coding defensively. Like, what if someone changes your CSV file, your data file? Ideally, that won't happen. But even if it does now, because I'm using a dictionary reader that's going to infer from that first row for me what the columns are called, my code just keeps working. And so it keeps getting, if you will, better and better. Any questions now on this approach?
Yeah, what is the importance of new line CSV file?
What's the importance of the new line in the CSV file? It's partly a convention. In the world of text files, we humans have just been for decades in the habit of storing data line by line. It's visually convenient. It's just easy to extract from the file because you just look for the new lines. So the new line just separates some data from some other data. We could use any other symbol on the keyboard, but it's just common to hit enter to just move the data to the next line. Just a convention. Other questions?
It seems to be working fine if you just have name and home. I'm wondering what will happen if you want to put in more data. Say you wanted to add the house to both the name and the home.
Sure, if you wanted to add the house back. So if I go in here and add house last, and I go here and say Gryffindor for Harry, Gryffindor for Ron, and Slytherin for Draco. Now I have 3 columns, effectively, if you will. Home on the left, name in the middle, house on the right, each separated by commas with weird things like number 4, comma, privet drive, still quoted. Notice if I go back to students.py and I don't change the code at all and run Python of students.py, it still just works. And this is what's so powerful about a dictionary reader. It can change over time. It can have more and more columns. Your existing code is not going to break. Your code would break, would be much more fragile, so to speak, if you were making assumptions like the first column's always going to be name. The second column's always going to be house. Things will break fast if those assumptions break down. So not a problem in this case. Well, let me propose that besides reading CSVs, let's at least take a peek at how we might write a CSV too. If you're writing a program in which you want to store not just students' names, but maybe their homes as well in a file, how can we keep adding to this file? Let me go ahead and delete the contents of students.csv and just re-add a single simple row, name, comma, home, so as to anticipate inserting more names and homes into this file. And then let me go to students.py and let me just start fresh so as to write out data this time. I'm still going to go ahead and import CSV. I'm going to go ahead now and prompt the user for their name. So input, quote unquote, what's your name, question mark. And I'm going to go ahead and prompt the user for their home. So home equals input, quote unquote, where's your home, question mark. Now I'm going to go ahead and open the file, but this time for writing instead of reading as follows. With open, quote unquote, students.csv, I'm going to open it in append mode so that I keep adding more and more students and homes to the file rather than just overwriting the entire file itself. And I'm going to use a variable name of file. I'm then going to go ahead and give myself a variable called writer, and I'm going to set it equal to the return value of another function in the CSV module called csv.writer. And that writer function takes as its sole argument the file variable there. Now I'm going to go ahead and just do this. I'm going to say writer.writeRow, and I'm going to pass into writeRow the line that I want to write to the file, specifically as a list. So I'm going to give this a list of name, comma, home, which of course are the contents of those variables. Now I'm going to go ahead and save the file. I'm going to go ahead and rerun Python of students.py, hit enter, and what's your name? Well, let me go ahead and type in Harry as my name, and number 4, comma, privet drive, enter. Now notice that input itself did have a comma, and so if I go to my CSV file now, notice that it's automatically been quoted for me so that subsequent reads from this file don't confuse that comma with the actual comma between Harry and his home. Well, let me go ahead and run it a couple of more times. Let me go ahead and rerun Python of students.py. Let me go ahead and input this time Ron and his home as the borough. Let's go back to students.csv to see what it looks like. Now we see Ron, comma, the borough has been added automatically to the file. And let's do one more. Python of students.py, enter. Let's go ahead and give Draco's name and his home, which would be Malfoy Manor. Enter. And if we go back to students.csv, now we see that Draco is in the file itself. And the library took care of not only writing each of those rows per the function's name, it also handled the escaping, so to speak, of any strings that themselves contained a comma, like Harry's own home. Well, it turns out there's yet another way we could implement this in Draco manner. Enter. And if we go back to students.csv, now we see that Draco is in the file itself. And the library took care of not only writing each of those rows per the function's name, it also handled the escaping, so to speak, of any strings that themselves contained a comma, like Harry's own home. Well, it turns out there's yet another way we could implement this same program without having to worry about precisely that order again and again and just passing in a list. It turns out if we're keeping track of what's the name and what's the home, we could use something like a dictionary to associate those keys with those values. So let me go ahead and back up and remove these students from the file, leaving only the header row again, name, comma, home. And let me go over to students.py. And this time, instead of using CSV Writer, I'm going to go ahead and use csv.dictWriter, which is a dictionary writer that's going to open the file in much the same way, but rather than write a row as this list of name, comma, home, what I'm now going to do is follows. I'm going to first output an actual dictionary, the first key of which is name, colon, and then the value thereof is going to be the name that was typed in. And I'm going to pass in a key of home, quote unquote, the value of which, of course, is the home that was typed in. But with dictWriter, I do need to give it a hint as to the order in which those columns are when writing it out so that subsequently they could be read even if those orderings change. Let me go ahead and pass in field names, which is a second argument to dictWriter, equals, and then a list of the actual columns that I know are in this file, which of course are name, comma, home. Those times in quotes because that's indeed the string names of the columns, so to speak, that I intend to write to in that file. All right, now let me go ahead and go to my terminal window, run Python of students.py this time. I'll type in Harry's name again. I'll again type in number 4, comma, privet drive, enter. Let's now go back to students.csv, and voila, Harry's back in the file, and it's properly escaped or quoted. I'm sure then if we do this again with Ron and the burrow, and let's go ahead and run it one third time with Draco and Malfoy Manor, enter. Let's go back to students.csv, and via this dictionary writer, we now have all three of those students as well. So whereas with CSV Writer, the onus is on us to pass in a list of all of the values we want to put from left to right. With a dictionary writer, technically they could be in any order in the dictionary. In fact, I could just have correctly done this, passing in home followed by name, but it's a dictionary. And so the ordering in this case does not matter so long as the key is there and the value is there. And because I have passed in field names as the second argument to dictWriter, it ensures that the library knows exactly which column contains name or home, respectively. Are there any questions now on dictionary reading, dictionary writing, or CSVs more generally?
Is there any specific situation for me to use single quotation or double quotation? Because after the print, we use single quotation to represent the key of the dictionary. But after the reading or writing, we use the double quotation.
It's a good question. In Python, you can generally use double quotes or you can use single quotes, and it doesn't matter. You should just be self-consistent so that stylistically your code looks the same all throughout. Sometimes, though, it is necessary to alternate if you're already using double quotes, as I was earlier for a long F string. But inside that F string, I was interpolating the values of some variables using curly braces, and those variables were dictionaries. And in order to index into a dictionary, you use square brackets and then quotes. But if you're already using double quotes out here, you should generally use single quotes here, or vice versa. But otherwise, I'm in the habit of using double quotes everywhere. Others are in the habit of using single quotes everywhere. It only matters sometimes if one might be confused for the other. Other questions on dictionary writing or reading?
Yeah, Daily. My question is, can we use multiple CSV files in any program?
Absolutely. You can use as many CSV files as you want, and it's just one of the formats that you can use to save data. Other questions on CSVs or file I/O?
Thanks for taking my question. So when you're reading from the file, you had the as a dictionary, you had the fields called. Couldn't you just call when you're reading? Couldn't you just call the row? In the previous version of the students .py file, when you're reading each row, you were splitting out the fields by name. Yeah. So when you're appending to the students list, can you just call for row in reader students.append row rather than naming each of the fields?
Oh, very clever. Short answer, yes. Insofar as dict reader returns one dictionary at a time, when you loop over it, row is already going to be a dictionary. So yes, you could actually get away with doing this, and the effect would really be the same in this case. Good observation. How about one more question on CSVs?
Yeah, when reading in CSVs from my past work with data, a lot of things can go wrong. I don't know if it's a fair question that you can answer in a few sentences, but are there any best practices to double check that sort of no mistakes occurred?
It's a really good question. And I would say in general, if you're using code to generate the CSVs and to read the CSVs, and you're using a good library, theoretically, nothing should go wrong. It should be 100% correct if the libraries are 100% correct. You and I tend to be the problem. Like when you let a human touch the CSV, or when Excel or Apple Numbers or some other tools involved that might not be aligned with your code's expectations, things then, yes, can break. The goal, really, sometimes, honestly, the solution is manual fixes. You go in and fix the CSV, or you have a lot of error checking, or you have a lot of try except just to tolerate mistakes in the data. But generally, I would say if you're using CSV or any file format internally to a program to both read and write it, you shouldn't have concerns there. You and I, the humans, are the problem, generally speaking, and not the programmers, the users of those files instead. All right, allow me to propose that we leave CSVs behind, but to note that they're not the only file format you can use in order to read or write data. In fact, they're a popular format, as is just raw text files, .txt files, but you can store data really any way that you want. We've just picked CSVs because it's representative of how you might read and write from a file, and do so in a structured way, where you can somehow have multiple keys, multiple values, all in the same file, without having to resort to what would be otherwise known as a binary file. So a binary file is a file that's really just zeros and ones, and they can be laid out in any pattern you might want, particularly if you want to store not textual information, but maybe graphical or audio or video information as well. So it turns out that Python is really good when it comes to having libraries for really everything. And in fact, there's a popular library called Pillow that allows you to navigate image files as well, and to perform operations on image files. You can apply filters a la Instagram. You can animate them as well. And so what I thought we'd do is leave behind text files for now and tackle one more demonstration, this time focusing on this particular library and image files instead. So let me propose that we go over here to VS Code and create a program ultimately that creates an animated GIF. These things are everywhere nowadays in the form of memes and animations and stickers and the like. And an animated GIF is really just an image file that has multiple images inside of it. And your computer or your phone shows you those images one after another, sometimes on an endless loop, again and again. And so long as there's enough images, it creates the illusion of animation, because your mind and mine kind of fills in the gaps visually and just assumes that if something is moving, even though you're only seeing 1 frame per second or some sequence thereof, it looks like an animation. So it's like a simplistic version of a video file. Well, let me propose that we start with maybe a couple of costumes from another popular programming language. And let me go ahead and open up my first costume here, number 1. So suppose here that this is a costume, or really just a static image here, costume1.gif. And it's just a static picture of a cat, no movement at all. Costume here, number 1. So suppose here that this is a costume, or really just a static image here, costume1.gif. And it's just a static picture of a cat, no movement at all. Let me go ahead now and open up a second one, costume2.gif, that looks a little bit different. Notice, and I'll go back and forth, this cat's legs are a little bit aligned differently, so that this was version 1. And this was version 2. Now, these cats come from a programming language from MIT called Scratch that allows you very graphically to animate all this and more. But we'll use just these 2 static images, costume 1 and costume 2, to create our own animated GIF that after this you could text to a friend or message them, much like any meme online. Well, let me propose that we create this animated GIF, not by just using some off-the-shelf program that we downloaded, but by writing our own code. Let me go ahead and run code of costumes.py and create our very own program that's going to take as input 2 or even more image files and then generate an animated GIF from them by essentially creating this animated GIF by toggling back and forth endlessly between those 2 images. Well, how am I going to do this? Well, let's assume that this will be a program called costumes.py that expects 2 command line arguments, the names of the files, the individual costumes that we want to animate back and forth. So to do that, I'm going to import sys so that we ultimately have access to sys.argv. I'm then, from this pillow library, going to import support for images specifically. So from PIL, import image, capital I, as per the library's documentation. Now I'm going to give myself an empty list called images, just so I have a list in which to store 1 or 2 or more of these images. And now let me do this. For each argument in sys.argv, I'm going to go ahead and create a new image variable, set it equal to this image dot open function, passing in arg. Now, what is this doing? I'm proposing that eventually I want to be able to run Python of costumes.py, and then as command line arguments specify costume1.gif space costume2.gif. So I want to take in those file names from the command line as my arguments. So what am I doing here? Well, I'm iterating over sys.argv, all of the words in my command line arguments. I'm creating a variable called image, and I'm passing to this function image.open from the pillow library that specific argument. And that library is essentially going to open that image in a way that gives me a lot of functionality for manipulating it, like animating. Now I'm going to go ahead and append to my images list that particular image. And that's it. So this loop's purpose in life is just to iterate over the command line arguments and open those images using this library. The last line is pretty straightforward. I'm going to say this. I'm going to grab the first of those images, which is going to be in my list at location 0, and I'm going to save it to disk. That is, I'm going to save this file. Now, in the past, when we use CSVs or text files, I had to do the file opening. I had to do the file writing, maybe even the closing. I don't need to do that with this library. The Pillow library takes care of the opening, the closing, and the saving for me by just calling save. I'm going to call this save function, and just to leave space, because I have a number of arguments to pass, I'm going to move to another line so it fits. I'm going to pass in the name of the file that I want to create, costume.gif. That will be the name of my animated GIF. I'm going to tell this library to save all of the frames that I pass to it. So the first costume, the second costume, and even more if I gave them. I'm going to then append to this first image, the image is 0, the following images, equals this list of images. And this is a bit clever, but I'm going to do this. I want to append the next image there, image is 1. And now I want to specify a duration of 200 milliseconds for each of these frames, and I want this to loop forever. And if you specify loop equals 0, that is time 0, it means it's just not going to loop a finite number of times, but an infinite number of times instead. And I need to do one other thing. Recall that sys.argv contains not just the words I typed after my program's name, but what else does sys.argv contain? If you think back to our discussion of command line arguments. What else is in sys.argv besides the words I'm about to type, like costume1.gif and costume2?
Yeah, so we'll actually get in the original name of the program we want to run, the costumes.py.
Indeed, we'll get the original name of the program, costumes.py in this case, which is not a GIF, obviously. So remember that using slices in Python, we can do this. If sys.argv is a list, and we want to get a slice of that list, everything after the first element, we can do 1:, which says start at location 1, not 0, and take a slice all the way to the end. So give me everything except the first thing in that list, which, to Mackenzie's point, is the name of the program. Now, if I haven't made any mistakes, let's see what happens. I'm going to run Python of costumes.py, and now I'm going to specify the two images that I want to animate. So costume1.gif and costume2.gif. What is the code now going to do? Well, to recap, we're using the sys library to access those command line arguments. We're using the pillow library to treat those files as images, and with all the functionality that comes with that library. I'm using this images list just to accumulate all of these images one at a time from the command line. And in lines 7 through 9, I'm just using a loop to iterate over all of them and just add them to this list after opening them with the library. And the last step, which is really just one line of code broken down to 3 so that it all fits, I'm going to save the first image, but I'm asking the library to append this other image to it as well. Not bracket 0, but bracket 1. And if I had more, I could express those as well. I want to save all of these files together. I want to pause 200 milliseconds, a fifth of a second in between each frame, and I want it to loop infinitely many times. So now, if I cross my fingers as always, hit enter, nothing bad happened, and that's almost always a good thing. Let me now run code of costumes.gif to open up in VS Code the final image, and what I think I should see is a very happy cat. And indeed. So now we've seen not only that we can read and write files via textually, we can read and now write files that are binary, 0s and 1s. We've just scratched the surface. This is using the library called Pillow, but ultimately this is going to give us the ability to read and write files however we want. So we've now seen that via file I/O we can manipulate not just textual files, be it TXT files or CSVs, but even binary